Alright, today we're going to be reviewing 4C notes. So our goal today is to learn to graph the different forms of a quadratic. So we've focused so far on just the vertex form of our quadratic. Today we're going to look at standard form and intercept form. So you need to be able to graph a quadratic in any of these three forms. First, let's look at standard form. So standard form looks like the following. Y is equal to ax squared plus bx plus c. Now you still want to always find your vertex. So this formula gives you your vertex. So you need to memorize that formula. So to find the x value of the vertex, x is equal to the opposite of b over 2a. And then once you find x, you're going to plug it back into your equation and find the corresponding y value. That's going to give you the vertex. Now, an easy thing with standard form, C is always the y-intercept. So 0C is always going to be a point on your parabola. All right, let's look at the following examples. So let's graph y is equal to x squared minus 2x minus 1. All right, so here A is that lead coefficient, so A is 1. Since A is positive, my graph is going to face up. So I know it's going to look like this when I'm done. All right, let's find the vertex. All right, here's where we require some math. So x is equal to the opposite of b over 2a. Well, in this case, b is negative 2. So the opposite of negative 2 over 2 times 1. So you get 2 over 2, which is equal to 1. So the x value of my vertex is 1. Now we need to find the y value. So you're going to take that 1 and you're going to plug it in for all the x's. So y is equal to 1 squared minus 2 times 1 minus 1. So 1 minus 2 minus 1, which is equal to negative 2. So the vertex has the point 1, negative 2. Now all parabolas have an axis of symmetry, and that axis of symmetry is always the value, x equals the value of the x coordinate for the vertex. So x equals 1. All right, let's graph this and we'll talk about what D is, a minimum or a maximum. All right, y-intercept, my C value is negative 1, so my y-intercept is 0, negative 1. Now keep in mind our goal is to plot at least 5 points on our graph. So now we've gotten 3 so far, or 3, I'm going to reflect this one. All right, so let's start graphing this and see what else we need. So 1, negative 2, that's the vertex, and then 0, negative 1. Now where I'm talking about that third point, remember that line of symmetry is coming in here at x equals 1. So I can reflect over that line of symmetry, and that's going to give me another point. So now I only need 2 more points. All right, actually 1 more point, then I'm going to reflect that to get my 5th point. Now you have a couple of options here. You can pick a value of x and plug it in and find the corresponding y. That's always an option. Or we can go back to those parent points again. So here again, we can always use the parent points like we did in the vertex form. So let's look. All right, parent points. Now I only need my positive side. I only need 1/2 of this. So let's look at 0, 1, and 2, which gives me 0, 1, and 4. Now if you're going to use parent points, remember we're counting. We're counting from that vertex. So at my vertex, 0, 0, right 1, up 1 I've already got, but let's go right 2, up 4. 1, 2, 3, 4, and then reflect it, and there's your 5th point. Now remember this parabola keeps on going, so put arrows on the end of that. So 5 points will make a good graph. Now if more points fit, you can more than welcome to put more points on your graph. All right, so see this vertex? It's the lowest point on my graph, so this is going to make this a minimum. There's a minimum at the y value, negative 2. So the minimum at negative 2. Okay, there's one example in standard form. Let's look at a couple more. All right, standard form. So we got y equals 2x squared plus 6x plus 3. So let's find the vertex. Okay, so we'll have to do x is equal to the opposite of b, which in this case is 6, over 2 times 2, which is negative 6/4, which is negative 3/2. Okay, now we're going to find the corresponding y value. We'll give ourselves some more room here to work. All right, let's plug in and find y. So 2 times negative 3/2 squared plus 6 times negative 3/2 plus 3. All right, do some math. 9/4 plus negative 9 plus 3. All right, clean this up. That gives me 9/2 minus 6, which gives me negative 3/2. So my vertex is negative 3/2, negative 3/2. All right, let's graph that. So negative 1.5, negative 1.5. So here's my vertex. All right, remember my goal is to have 5 points. Okay, so y-intercept, that's easy, that's a gimme. So my y-intercept here is 0, 3. So 1, 2, 3. All right, now we got axis of symmetry is coming in, right, at x equals negative 3/2. So let's use that axis of symmetry, negative 3/2. Okay, so I'm going to reflect that y-intercept. So there's, now I've got 3 points. That means I need one more point to reflect. All right, now because my vertex is not on a whole point, it's at negative 3/2, negative 3/2, I probably wouldn't use the parent points here. This would be an example of where I would plug in, pick a value for x, and find the corresponding value for y. So I'm going to use x is equal to negative 1 and find the corresponding y value. And you always have this option. Like I said, you've got to kind of think about your problem and what is the best way, the most efficient way to get those needed points. All right, what do I got? I got 2 times 1 minus 6 plus 3. 2 minus 6 plus 3, negative 1. So negative 1 is a point. Now, because I plugged into the original equation, this is a true point on my graph. I'm not counting from there. I'm actually graphing that point. And you got to know the difference when to do each. Okay, so negative 1 is a point, and then I can reflect it. And there are my 5 points that I need. Connect my dots and put arrows on the end. Okay. All right, domain, practice those vocab words. It's going to be all reals. And my range, this thing has a minimum at negative 3/2. It is closed. And it goes up to infinity. So fraction shouldn't be, if you have a fractional vertex, it shouldn't be a problem. All right, one more of these before we move on to the next form. Okay, so we got here. All right, notice here we don't have a b value. All right, a couple of different ways. You may already recognize how to graph this. We've done some of these previously. If not, I can show you how to do it in standard form. So find the vertex first. So the opposite of b, which is 0, over 2 times 1. So my x is 0. Find the corresponding y value, which is negative 4. So my vertex is 0, negative 4. 1, 2, 3, 4. All right, which is also my y-intercept. So it only got me 1 point. Here again, since my vertex is at a whole point, 0, negative 4, I personally would use the parent points. 0, 1, 2, 0, 1, 4. Okay, so now because I'm using parent points, I'm counting. So I've got go right 1, up 1, reflect it, right 2, up 4, and then reflect it. And there are my 5 points. And here again, I could fit more. I could do 3, 9. All right. And if this was an inequality, you would need to do, like I said, enough to get you off the graph. All right, domain, all reals, and range is from negative 4 to infinity. Now, notice all my examples had a positive A. All my A's were positive. That doesn't have to be the case. A could be negative. It was just the examples I picked. All right, so that's standard form. So you got to memorize how to find the vertex, opposite of B over 2A. So the next thing we're going to look at is intercept form. So in intercept form, it's been factored. You have two factors. All right, and P and Q, notice that to find the vertex, it's P plus Q divided by 2. These are the zeros. So I like to think about to find X, X is the average of the zeros. Okay, the average of the zeros. That's how we find X. We don't need the P and Q. We just need to find the zeros in this factored form, this intercept form, because these are going to be the y-intercepts, hence the zeros, and we're going to graph those. All right, now because I haven't had a negative one, let's change this problem to negative 2 times x plus 3 times x minus 1. So change that 2 to a negative, because we haven't had a negative example. All right, so now since we changed it, my a is negative 2, so this is going to open down. We need to find the zeros of this function. So we're going to take each of our factors and set them equal to 0. So x is equal to negative 3 and x is equal to 1. All right, so P and Q. So negative 3, 0 is going to be a point on my graph, and 1, 0 is going to be a point on my graph. So there's 2 points already, so we need to find 3 more. All right, let's do that by finding the vertex. So my vertex, we need to average those zeros. So the x value of my vertex is negative 3 plus 1 divided by 2. So negative 2 divided by 2, which is negative 1. To find the y value, we always go back and plug back into the original graph, original function. So negative 2, negative 1 plus 3, and negative 1 minus 1. So negative 2 times negative 2. So positive 8. So my vertex is 1, 8. Okay? All right, so there's 3 points. We need 2 more. So let's graph what we've got and see what we need and decide how we're going to go about getting those extra points that we need. All right, so we've got 1, 8. I'm sorry, negative 1, 8. Write it down correctly. Negative 1, 8. All right, we've got negative 3, 0. And we've got 1, 0. All right, we have a couple of options here. We could use parent points again. Okay, we could find the y-intercept. That would give us another point. Or we could pick a value, plug it in for x, and find the corresponding y. So you have 3 options to get the 2 more points. All right, I'm going to use parent points because, like I said, I want you to practice using that because I think once you get really good with it, it's going to be the most efficient way to graph. And then we'll back it up a couple of other ways just to, like I say, show you your options. All right, so what have I got? I've got 0, 1, 2, 0, 1, 4. Now my a is negative 2. So my y values are going to change. Now if you're using parent points, remember we're counting. These are not coordinates on my graph. It's counting from the vertex. So write 1 down 2 and then reflect it. All right, and then 2, negative 8 should be the point that's down here. Okay, so here again, if we need more points, take it off the graph. We could go 3, 9. But I want you to have at least 5 points. All right, so that's using the parent points. All right, we could also define the y-intercept. All right, remember to find the y-intercept, your x's are 0. So that would give us negative 2 times 3 times negative 1, which is positive 6. And that's what that point is, 0, 6. So you do have options, but it's all about getting those 5 points. All right, so let's look at one more of these. All right, here again, this is in intercept form. It's got the parentheses and it's been factored. Notice the parentheses are not squared like they are in vertex form. You got to be able to recognize the different forms. All right, here my lead coefficient is 1, so A is 1, so this one's opening up. All right, we need to find our zeros, so set each factor equal to 0. So x is 0, so 0, 0 is a point, and x is equal to 4, that means 4, 0 is a point. All right, let's find the vertex. So that means we want to average the zeros. So 0 plus 4 divided by 2. 4/2 is 2. Take that 2 and plug it back in and find the corresponding y value. So 2, -2 is equal to -4. So 2, -4 is my vertex. All right, my intercepts are 0, 0, and 4, 0. All right, so I'm going to need another point. So let's graph what we've got. So 2, -4. I've got 0, 0, and I've got 4, 0. All right, I need another point. Y-intercept doesn't do me any good because I've already started on my graph. All right, here again, you could choose a value for x, plug it in, find the corresponding y values. But I'm going to use, and hopefully you said, yep, parent points. So I got 0, 1, 2, 0, 1, 4. And my A is 1, so they're not going to change. Remember, I'm counting now. So from our vertex, I'm going to go right 1, up 1, and reflect it. And there's my 5 points. I could also go right 3, up 9. And then reflect that too. Okay, but my goal is, like I said, to get 5 good points. All right, put the arrows on the end because it keeps on going. So now you have the 3 forms of a parabola, of a quadratic: standard form, vertex form, and intercept form. And like I said, you need to be able to distinguish between the 3 because they only have their unique ways of being able to being able to graph them. All right, let's do increasing and decreasing intervals. Increasing interval, so we're going up here and down from left to right. So we always do it in terms of x. It's always open, so 2 to infinity. And then -infinity to 2 is my decreasing interval. All right, one more quick topic. All right, it says change into standard form. So that means I want to change this. This is currently in intercept form. You want it to make it look like this in standard form. All right, so what you're going to do is you're going to FOIL first. So we're going to leave that 1/2 alone for a bit. And we're going to FOIL and get x squared minus 5x plus 4. And now you're simply going to distribute that 1/2. Leave them as fractions. 4/2 is 2. Okay, so that's your final answer. So nothing too difficult here. Just be careful and don't make any silly mistakes with your algebra. Okay, so that's an example in intercept form. All right, look at this one. This is in vertex form. And you want to change it to standard form. All right, notice my little note here. You're going to FOIL this first. So we're going to leave that -1 alone, and we're going to FOIL 2x. So this is 2x plus 1 times 2x plus 1. Don't forget about that -3. All right, what do we get? Y is equal to -1. You're going to get 4x squared plus 4x plus 1, and then -3. Now make sure you distribute that -1 before you combine that like term. So this is going to be -4x squared minus 4x minus 1 minus 3. Now combine these like terms. So final answer, -4x squared minus 4x minus 4. Now this is in standard form. Do not do anything with this. Don't divide. You're not solving it. You're just putting it in standard form, a different form. You can't divide through and get rid of -4 because it's not set equal to 0. It's set equal to y. All right, please, if you have any questions, ask them in class. Thanks.